you will frequently be given values that are not in your SI base units, such as millimeters when you need to be in meters. Hours for time, you have to be in seconds. I gave you something in micrograms that has to be in kilograms. So how do you convert these things? This method is a standard format that we use. I didn't make it up. A lot of people just want to short circuit this, and based on my experience, more often than not when they do that, they blow it. And if you can't convert to the correct units, everything else is wrong. All right? So, this is a basic step that you need to be able to do. All right, I can do this in my head also, but that's not the point of this question. The point is to show you the format for doing this. I'm sure you all remember fondly stoichiometry from chemistry. That is a conversion problem where you're going from perhaps grams to moles to number of atoms, or vice versa. I found that to be a little more difficult than this, but that's still a basic conversion problem. All right, here we go. The first thing to do, we're given a value. We're in the lab. We measure something out to be 7.2 millimeters. And then we need to do something with it. Well, we know we have to be in meters. We can't stay in millimeters. It's not SI. So the first thing is write down what you're given. You're given 7.2 millimeters. When you're doing these problems, please don't tell me I don't even know where to start, because where you start is just with what you're given. Write it down. 7.2 millimeters. Write down the times symbol and a line. Write down what you're given. 7.2 millimeters. The time symbol and a line. Now, notice that this is in the numerator, although you don't normally put that over 1, but that's millimeters over 1, just like this is meters over 1. So it's not 1 over meters, it's meters over 1. So I start out with the millimeters in the numerator, and I want to end up with meters in the numerator. Okay? So since these are in the numerator, I want these to cancel out. You can cancel and multiply units just like you do variables. You know that x times x is x squared. X divided by x cancels out to 1, right? So I have millimeters in the numerator. I want them to cancel out. I don't want millimeters anywhere in my final answer. And so I'm going to put millimeters in the denominator. I want meters to be in the numerator. This next step is your conversion step. You have to ensure, this is where some students mess up, you have to ensure that the numerator and denominator represent the same length. What I mean by that, as a separate example, if you, for example, 7 days is the same as 1 week. All right? They represent the same duration of time. So in here, this is a distance unit, right? So the numerator and denominator have to represent the same length, the same distance. Another one might be $2 is the same as 200 cents. Okay? I guess I put that order. But the point being that they're worth the same in the numerator and denominator. Okay? That's what I'm getting at. Be sure that's true when you're doing these. Otherwise, there's no point in doing the rest of the problem because it's all garbage. All right. Now, when I do this, I always put a 1 in front of the unit that has the SI prefix. Notice that this is millimeter. Now ask yourself, what's milli represent? Milli is 10 to the negative 3. Milli, the SI prefix milli is 10 to the negative 3. Whether it's a millimeter, a millisecond, a milligram, a milli whatever, milli vanilli. Milli, the SI unit milli, is 10 to the negative 3. Now you either put millimeter, millimeter, or 10 to the negative 3 meters. 10 to the negative 3 meters or millimeter. I have to put a 1 in here to make it a mathematical statement. but 10 to the negative 3 meters or millimeter. Don't put both. You don't put millimeter. Don't put 10 to the negative 3 millimeter. It's 10 to the negative 3 in front of the meters or the m, the milli, in front of the meters. Okay? Now, I have milli in the numerator and milli in the denominator. It doesn't matter whether or not they're exactly over one another. The fact that I have milli in the numerator and milli in the denominator, they cancel. Just like that. Okay. Notice the only uncanceled unit is the one I want, because there's nothing to cancel the meters all by themselves. So now I can do my math. So 7.2 times 10 to the negative 3 meters. 7.2 times 10 to the negative 3 meters. And that's my answer. Over here, 3.5 hours to seconds. Write down what you know. 3.5 hours times and a line. That's how you start. I want to go from hours to seconds. Now I can go from hours to minutes to seconds, or I can go right from hours to seconds. There are 3,600 seconds in an hour. If you forget that, it's 60 seconds in a minute, 60 minutes in an hour. Just to make that point, I'm going to go from hours to minutes. And I know that 1 hour is 60 minutes. Again, I could go straight to seconds, but 1 hour is 3,600 seconds. But I just want to make the point here. So that's hour, hour. Get hour in the numerator, hour in the denominator. Those units cancel. I'm left with 3.5 times 60 minutes. Now, I could go ahead and calculate that out, and I'd be in minutes. But it is absolutely okay. In fact, we do this quite a lot in science. The math people don't really like it. But I mean, this is just the technique we use. All right. You can continue this on without multiplying out yet. All right, now I'm in minutes. I don't want to be in minutes. I want to be in seconds. Now, 1 minute is 60 seconds. And you all know that. Your minutes cancel. Now, the only uncanceled unit is seconds. 60 times 60 is 3,600. That's how we could have gone right from 1 hour to seconds is 3,600 seconds. So 3.5 times 60 times 60. 3.5. That is 12,600. 12,600 seconds. Now, my significant figures aren't correct because this is only 2 significant figures. Remember that these are not measured values, so they don't count. This is only 2 significant figures. This makes people uncomfortable. But this would be 13. The correct way to write this would be 13,000 seconds, because that you have to round it to 2 significant figures, because that's only 2 significant figures. You're not being less precise. You're showing that you actually have an understanding of significance. And then this last one. 5.67 times 10 to the 4 micrograms. I'm going to go from micrograms to grams first. Why? Because I know that micro is 10 to the negative 6. Micro is the SI prefix 10 to the negative 6. Those cancel. And then I'm in grams. I want to be in kilograms. So I'm going to go from grams to kilograms. And I know that 1 kilogram is 10 to the positive 3 grams. Grams cancel. And then my answer is 5.6 times 10 to the 4, 5.67. 4 times 10 to the negative 6 is 10 to the negative 2, 10 to the negative 5 kilograms. I just did my prefixes here. 10 to the 4 times 10 to the negative 6 is 10 to the negative 2, divided by 10 to the 3. When you divide, you subtract the exponent. It comes to negative 5. All right? And that's the answer.